It has been found that adding a nanotextured surface to titanium implants not only will decrease the chances of getting infection, but also increases the implant's adhesion to the bone. The image shown is what a hip implant looks like after nanotexturing is added. The animation shows the process that titanium implants undergo to create nanotubes on the surface of the implants. A brief explanation of the nanotexturing process is the implant is dipped into an electrolyte solution and subject to an electrical current for a specific time. Based on the implant surface area, the current etches away the metal surface, creating nanotubes. Currently, the process is only being done on a small scale. However, after years of development, it is ready to be taken to a larger scale. Our goal is to develop a digital way of presenting the nanotexturing manufacturing process to potential orthopedic companies to bring to large-scale manufacturing. This digital simulation must be simple. Any operator should be able to reason one's way through. It will show how the process will potentially work with a focus on how long implants need to stay in the solution and how often the various chemicals deplete.
Upon opening the tool, follow the instructions to select the desired system, batch or multi-batch, by clicking on the appropriate tab. Each tab contains step-by-step tutorial instructions for running each system. For the batch system, launch and input the parameters required in the User Input tab, including the tank size and units, the type of implant, the number of implants per batch, and the number of batches. Once the inputs have been selected, clicking on the Plot button will run the data and give outputs based on the selected scenario. The Output 1 tab shows general plots, including the number of implants, area etched, and current draw. The Output 2 tab shows electrolyte-specific plots as well as an alarm for the electrolyte level. The Fluorine-related Output 1 tab shows plots specific to the fluorine as well as an alarm for the fluorine concentration. The Fluorine-related Output 2 tab shows additional fluorine-related outputs. To run a simulation based on a multi-batch system, select the appropriate tab from the system selection. Follow the tutorial instructions to launch the system and input values such as the tank size and units. The spinner represents how many batches to be run simultaneously. Within the input table, select the implant type from the drop-down menu. Input the desired implants per batch, the number of batches, and the desired time to start each specific batch. Click the Plot button to run the data and give outputs based on the selected scenario.
We have created a resource using MATLAB for our customer contact, Dr. Friedrich, to present to the orthopedic industry with the intention of bringing the nanotexturing process from its current operation on a small scale to large-scale manufacturing. The next steps in the process include adding implant types, such as spinal or dental implants. Additionally, silver fluoride can be added to the electrolyte mixture to further increase antibacterial properties of the implants. Data has shown that adding nanotubes reduced average MRSA infections by 70%, while adding nanotubes and the silver fluoride reduced infections by 95%. Team 22 would like to extend a special thank you to our advisor, Dr. Jaclyn Johnson, for all her help and support over the last 2 semesters. Also, thank you to Dr. Craig Friedrich and his team. His hard work on this technology allowed us the opportunity to design this virtual manufacturing process. Last but not least, we would like to acknowledge Dr. Bill Endres, Dr. Nancy Barr, and the entire staff that supported us during our time in senior design.